Hi everyone, welcome back. The learning goal for this video is given a temperature, you should be able to calculate the corresponding temperature on another scale. So you can see here, a digital ear thermometer is being used to measure body temperature. So you're measuring temperature quite often. You'll also measure temperature in the laboratory as well with our digital thermometers. So what is temperature? Well, temperature is a measure of how hot or cold an object is compared to another object. It helps us indicate the heat flow from the object with a higher temperature to the object with a lower temperature. And we will discuss heat flow later on in a different video. And as I stated before, temperature is measured using a thermometer. As you saw with the child, a digital ear thermometer was being used. In the laboratory, we also use digital thermometers as well. And so our primary learning objective in this video is to be able to convert between the different temperature scales. And you can see two of the scales here, Celsius and Fahrenheit. Now in the United States, we typically use Fahrenheit, but in science, we report many of our measurements in Celsius. And so for example, the normal range for temperature is about 98.6 to 96.8 degrees Fahrenheit. So that's normal range. Anything above 98.6 degrees Fahrenheit would be considered fever, and anything 105.8 and above is hypothermia. Anything 95 below the normal range would be hypothermia. And you can see the temperatures in Celsius on the other side of the thermometer. The temperature scales are Fahrenheit, which will represent degrees Fahrenheit, and Celsius, degrees Celsius. The temperature difference between boiling and freezing of water are divided into smaller units, and that's called degrees. And that's what we represent with that small circle there. On the Celsius scale, there are 100 degrees between the boiling and freezing point of water. On the Fahrenheit scale, there are 180 degrees between boiling and the freezing point of water. And that, like I said, is the core chemistry skill you will develop after watching this video and practicing some problems, is converting between the different temperature scales. Now there's another temperature scale called Kelvin. Scientists have learned that the coldest temperature possible is negative 273 degrees Celsius. And on the Kelvin scale, this is called absolute zero and is represented as 0K. We use the capital letter K for Kelvin. And there's no degree symbol in front of the K to represent temperature. There's no negative temperatures for Kelvin because 0 Kelvin's the coldest you can get. And something to also make note of is that the same size units as Celsius. Kelvin has the same size unit, Celsius, so 1 Kelvin is equal to 1 degree Celsius. And we'll come back to this in a little bit. This is kind of converting Fahrenheit to Celsius. So we'll discuss that in a little bit when we look at the temperature scales and practice some problems together. So let's look at those temperature scales. So we have a Kelvin thermometer, a Celsius thermometer, and a Fahrenheit thermometer. And each of them are in boiling water. And we can see here that once we reach the red line here in this thermometers, that's the temperature of the boiling water. So the boiling water is 100 degrees Celsius. If we're in Fahrenheit, that's 212 degrees Celsius. And if we're in Kelvin, that's 373 Kelvin. The freezing point of water is 0 degrees Celsius. So that's the 100 degrees difference between the freezing and the boiling point. The freezing point of water in Fahrenheit is 32 Fahrenheit. So there's a 180-degree difference between the freezing and the boiling point of water on the Fahrenheit scale. And the freezing point of water in Kelvin is 273 Kelvin. And once again, there's only a 100 Kelvin difference between the freezing and the boiling point. So that's the reason why a Kelvin, 1 Kelvin is equal to 1 degree Celsius. They're the same size. So you can see they're the same size, whereas Fahrenheit's a lot smaller, right, in comparison to Celsius and Kelvin. But as you saw in the previous page, there's going to be formulas you're going to use to help you convert between the temperature scales. All right, pause the video, try the study check on your own, and then come check your work with me when you're done. All right, what is the temperature at which water freezes? Is it 0 degrees Fahrenheit, 0 degrees Celsius, or 0 Kelvin? Good, hopefully you said 0 degrees Celsius. What is the temperature at which water boils? Excellent, 373 Kelvin. How many Celsius units are there between boiling and the freezing points of water? Good, there's 100. So how do we convert between Celsius and Fahrenheit? Well, to convert the temperatures between the Celsius and the Fahrenheit scales, we have to adjust for the size of the degrees. So as we said, there are 100 degrees Celsius between the freezing and boiling points of water, and there are 180 degrees Fahrenheit between the freezing and boiling points of water. So therefore, there's 180 degrees Fahrenheit is equal to 100 degrees Celsius. And if we put that as a ratio here, we can see that for every 1 degree Celsius, there are 1.8 degrees Fahrenheit. Now, not only do we have to adjust for the different degrees, but the starting points are also different for Celsius and Fahrenheit. So when we look at the different freezing points of water, 0 degrees and 30 degrees Fahrenheit, we can write temperature equations to convert between Fahrenheit and Celsius. So for example, if I wanted to calculate the temperature in Fahrenheit and I was given the temperature in Celsius, I would first need to take the temperature in Celsius and multiply by 1.8. So once again, that changes the degree from Celsius to Fahrenheit. And then I would need to add 32 to adjust the freezing point since they're off by 32 degrees. So the formula here is temperature in Fahrenheit is equal to 1.8 times temperature in Celsius plus 32. If you needed to obtain the temperature in Celsius from temperature in Fahrenheit, you can rearrange this equation. To do so, you would first subtract 32 from both sides so that it can cancel out on that side. So then we have temperature in Fahrenheit minus 32 is equal to 1.8 times temperature in Celsius. And then you would divide both sides of the equation by 1.8 so that it cancels out on the right and we can isolate temperature in Celsius. And so therefore your other equation that will be useful is temperature in Celsius is equal to temperature in Fahrenheit minus 32 divided by 1.8. Now you're going to be converting between different temperature scales for the rest of the semester. So let's talk about a plan to calculating temperature. As always, with any problem solving, state the given and needed quantities. And if you need to determine the temperature in a different scale, then write the temperature equation. And then your final step is to substitute the known values and calculate the new temperature. So let's do an example together. A person with hypothermia has a body temperature of 34.8 degrees Celsius. What is the temperature in degrees Fahrenheit? So once again, we always want to write our given. So we are given the temperature in Celsius is equal to 34.8 degrees Celsius. And we need to find the temperature in Fahrenheit. That's step one. Step two is to write the temperature equation. So temperature in Fahrenheit is equal to 1.8 temperature in Celsius plus 32. And then step three is to substitute in the known values and calculate the new temperature. So temperature in Fahrenheit is equal to 1.8 times 34.8 plus 32. And so when I plug that into my calculator, I take 1.8 times 34.8, and I get 62.64, and then I add 32, and I get, this is equal to 94.64 degrees Fahrenheit. Now, to report it to the correct number of significant figures, 1.8 is an exact number, and 32 is an exact number. So 1.8 times 34.8, just as a side note, this value was 62.64. And because it's multiplication, we would report to the fewer sig figs. So in this case here, we will report to two significant, or this is exact numbers, so we don't mind that one. We're just going to report to three significant figures. But I'm not going to round it, I'm just going to put an underline there. So I know to the tenths place. And then when we do addition, because this is an exact number, we don't take it into account when determining, the reporting our final answer. Same with 1.8 was an exact number, so we're not taking that number into account. So if I'm taking a number that is in the tenths place, and then I'm adding this, but we're not counting it because it's exact, then I have to report that answer to the tenths place because it's addition. So addition and subtraction is report your answer to the least number of decimal places. So in this case, it would have been to the tenths place. And so your final answer is 94.6 degrees Fahrenheit. This table is going to show us a comparison of different temperatures for many examples. So for example, room temperature, we'll work with room temperature a lot, is 70 degrees Fahrenheit, which is 21 degrees Celsius, which is 294 Kelvin. The coldest temperature possible, absolute zero, is 0 Kelvin, negative 273 degrees Celsius, negative 459 Fahrenheit. You see all sorts of different examples comparing the temperature scales. All right, go ahead and pause the video, try the study check on your own, and then check your work with me when you're done. All right, on a cold winter day, the temperature is negative 15 degrees Fahrenheit. What is that temperature in degrees Celsius? So once again, we're going to write the given. So the temperature in Fahrenheit is equal to negative 15 degrees Fahrenheit. And we need the temperature in Celsius. And so because we're converting from Fahrenheit to Celsius, we'll need to write down the equation. Temperature in Celsius is equal to temperature in Fahrenheit minus 32 divided by 1.8. And remember, 32 and 1.8 are exact numbers. We're going to plug in negative 15 minus 32 divided by 1.8. So I'm going to plug that into my calculator. So negative 15 minus 32. Be careful with the signs on your calculator. That's where I see more mistakes made. It's just simple calculator error when it comes to converting between the different temperature scales. So make sure whatever calculator you're using, you feel comfortable with it. and you're checking your work with me to make sure that you're inputting your data points properly. So -15 minus 32. I'm working with a graphing calculator, so I always press enter after that. I got -47 there. And then I divide by 1.8. And I get -26.11. But once again, because it's subtraction, then at first, and I got -47, that would go to the ones place. You're dividing by an exact number. So we're just going to keep it to those two sig figs. And so that's the reason why the final answer is -26 degrees Celsius. So to two sig figs there. All right, pause the video again, try the study check on your own, and then come check your work with me. Okay, what is normal body temperature? 37 degrees Celsius in kelvins. So once again, let's write our given. So temperature in Celsius is equal to 37 degrees Celsius. And we need to find the temperature in Kelvin. And so the formula for this, if you remember back, let's go back to this here, that the same degree Celsius is the same size as Kelvin, right? 1 degree Celsius is equal to 1 Kelvin. And the only difference is that, for example, the freezing point of water is 0 degrees Celsius and the freezing point is 273. So they have a difference of 273. And so therefore, coming back to this one here, we need to convert between Celsius and Kelvin. Temperature in Kelvin is equal to temperature in Celsius plus 273. So that's a good formula to know. And then also, if you needed to find Celsius, then that would be temperature in Kelvin minus 273. Now the equation we're going to use for this problem here is the first one that we wrote down. And so therefore, when we plug that into the equation, we have 37 plus 273. And so that gives us 310 Kelvin, which is letter B. All right, thank you for watching. And as always, email me with any questions.